Hello everyone, welcome back to the channel. Today we are going to continue with over part 3. Okay, so that is how to tune your model, how to hyper tune your model. Okay, if this is the first time you are watching this video, I just wanted to let you know what we have worked in the previous 2 parts, so you can go back and watch those videos too. Okay, so we are working from the start with the data set Brazil e-commerce data set. Okay, so the goal we set for this data set is to classify the customers' sentiments. Okay, so what was those sentiment, like a positive, negative, and neutral? Okay, so we have like classified these three different your sentiments. Okay, and in the part 1, I have already discussed at a deeper level the analysis plus visualization. Okay, if this is the first time you are watching this video and you don't have any experience for the e-commerce data set, then this series is best for you. Okay, and then in the second part we have worked on the model building, build the top 5 different models. Okay, so we have tried top 5 different models. Okay, so when we tried this, we got a random forest was working very good. We got 87% accuracy rather than the other models. Like we have applied the XGBoost, AdaBoost, logistic regression, and this got a very highest accuracy. So we have chosen this one to hypertune more. Okay, if we can increase the accuracy. So today in the part 3, we are going to hyper tune the model. Which model? Random forest. Okay. If you don't know what is hypertuning, why we need it, I will explain you as a layman first. Then I will tell you which different methods we are going to use today for the hypertuning, and then we will jump on to the practical example. Okay. I will again give you the very simple example. Let's say you are a student, right? You have given the math exam, right? And you got 87 marks out of 100, right? Like we got 87% accuracy out of 100% accuracy, right? Now, this was your internal exam, right? So let's suppose this was your internal exam. Now it's a time to come up for the final exam. Okay. So when you have given the internal exam, in this you worked on the, let me erase this one. Okay, first I will make you understand this one. So in the internal exam, you have worked on the algebra, you worked on the calculus, right? And you worked on the geometry. Okay, and to like you if you like you to get trained on all these subjects, you have applied the different methodologies. We can technical term, we can name it as a parameter, right? You have learned the algebra online, right? And plus you practice past 5 years questions. Okay, same with this one. Okay, so you did this, but you got a 87%, and what you want to do, you want to make a changes in this, right? So what you will do, instead of you will keep it same online, you will practice past 10 years now instead of 5 years. Okay. And then same with this one. Okay. You might think instead of including this one, I will like pick up a class test too for practice. Okay. So what is this? This is the parameters, right? You are making a changes in the strategy of becoming expert in math for your final exam. Okay. And this portion is known as hyper tuning. Okay. This is the same way. You trained the model previously using the default parameters. You did not set any specific parameter. You are just passing the default parameters in the random forest and it gives you the 87% accuracy. But you want to increase your numbers, right? In the final exam, you want 100 out of 100, or might be you require the 95 out of 100. Same with the model. You want to increase the accuracy of the model, right? What you will do? Either you will change your strategy of learning the content, or either you will do some more additions. What are those? This is called parameters, right? You are changing the parameters, because when we follow any strategy, we follow some parameters, right? So these are a practice. Instead of 5 years, 5 years is what? This is a parameter of your this strategy, right? And here you change the 5 to 10 years, and you did not add the parameter of pick up the class test to for the practice. You did not pick up it here, but you will pick up it here. So you are doing the more addition. So this is all parameters, and in technical term, we call it hypertuning. This means you are practicing more with the different learning strategies for your final exam. Okay, I hope it makes sense. What is a hyperparameter and why we need it? Okay. Okay, I will give you the one more layman example. It might help more you. Like for example, if you are setting the oven temperature for baking something, right? You will make changes. First, you will bake it at a 390 degrees Celsius, and then you will make it 450. It make better. It give you the better taste. Same thing. Okay. Now today we are going to use the the parameters as hypertune strategies. The first one is grid search CVS. This is very popular. We used to hypertune over models. Okay. What the grid search your CV does, it tries every combination of the parameter you define. Okay. Like a brute force approach. So what are those parameters? If I first you need to import the sklearn library, right? And then you can set the parameter. I will give you the just layman example here. How does it look like? But I will show you the what we call practical example too. Okay. So in the random forest, we will set the number of estimators. Okay. So you can give the combination of that one. So this one, something like that. You will say 100 and 200. So what your this parameter will do? Maximum depth. How much you want your model to be splitted, right? So 100 combination first work with the 10 depth, all combinations of this one. Then it will come with the 20 and then work with this one. This is the way how it will work. Okay. And then 20, if you are adding 20, then none. Okay. So 100 will work all these parameters and 200 will also work in all these parameters. This is how does it work. Okay. And there is another parameter, minimum split. Okay. So this is something like that. So now you have the two combination of this one. This is 2. And this is the 3 combination. This is 3. And 2 combination, let's say let's give an any value. Let's say 2 and 5. Let me clear this up. Okay. So we are minimum split. We are saying first time it will split in a 2 time and then 5 times. So how many splits? 2. So how many models it will generate? 2 multiplied by 3 multiplied by 2, 12. So it will create the 12 different models. And in the 12 different models, you might get first, you can say model 1. It is giving you the accuracy 87%. And at that, it use the parameter, let's say 100, 1, or you can say, let's say 1, 2, 3, something like that. Okay, and it is a 1. So this is going to be your best parameter. I'm just pointing out the random variable. This is not the actual value, but I'm just telling you it can be. Like when it gives you the 87% accuracy, this is a combination it has used. It used the number of estimate 100 and maximum depth it used only 9, or it can be 9. Maximum depth is 10 and minimum split it does only 1, right? Because it is picking up the every combination. And then it will give you, again, it will give 89%, and there will be the different parameters. So we will do the comparison of these 12 different models, and which model contains the highest accuracy with these parameters, that is known as best parameter. And then we will fit onto the model and use this model with these parameters for our deployment. This is the like the purpose of your hypertuning. Grid search CV. How does it? This is the way. How does it work? Okay. I hope it make a sense to you. Again, if you like want to, if you want to like connect it with the previous example, example, right? You are practicing for the 10 years, 5 years past papers. You have added this parameter. You got 89% marks. So you will always follow this strategy, right? This is the same way. And in this, like when we are talking about the grid search CV, this is a 12 model. Okay. And how many parameter? 3. 12, 3. So it will be the 3-fold CV and 36 total trainings. Okay. This is the actual your grid search CV model. How does it work? Okay. So 12 is what? Every combination. 12 model. And what is 3? 3-fold means because we are using the 3 parameters here. Okay. And now what is the biggest advantage of the grid search CV? This is find the best exact combination. This is the biggest advantage. It works well on a small search spaces. Okay. It is the disadvantage is it is a little bit slow. If the number of the parameter increases, it is not a good choice for the large data sets. But I will show you the another method too. So you can apply anyone. So in future you might have the small data set, then you can go with the grid search CV. Otherwise, you can pick up the other one, which I am going to tell you right now. So the next one is over the second method we will use today is the randomized search CV. Okay. So this is instead of trying in this, if you are going to use this one, instead of trying all, it randomly samples a fixed number of combination actually from the parameter grid. Okay. So if I will give you an example of here, let's say you have picked up the parameter again, estimators. Okay. So you need to use here randint. Okay. This is 100 and 300. Okay. And then again, maximum depth. Parameter name will remain same. Only the processing steps or technology strategy will be different. Above grid search CV, it was using every combination as I told you. Here it is not the case. Okay. This is a split. Just ignore the name of the parameter. This is I'm just writing roughly, but I will show you practically. Okay. So now it might only try the 10 combinations. Okay. Even there are 100 plus possibility. Okay. Let's say it is 100 and we have given the 2 parameter. Out of this, it only pick up the 10 parameter, like the 10 combinations. Okay. So this is the biggest advantage and this is very fast. This is the thing. Okay. This is very fast. It is a much faster useful when you don't need the perfect setting. It will because it is going to give you the random result, right? Because it is picking up the random parameters and it is going to try the random only the few combinations and give you the result. But if you want at a deeper level each combination, then you can go with the grid search CV but that will slow down your process. Okay, but we still have the like the solution for that one. The disadvantage of this random is might miss the exact best combination, because let's say if the first combination it pick up the random int, let's say 10, right? And it pick up the 9 and 1, right? After that it stopped, right? It did not pick up the next combination. Let's say it did not pick up the 28 to, it missed that, right? It is randomly picking up. Okay, and then let me remove this one. Okay, so it results very slightly with each run, because it is a random, you will find the every time different result, but it is a very faster for the large data sets. Okay, so now what we will do, we will jump onto the our practical example. But before that, I would like to tell you. So if you have the small data set, your both grid search CV and randomized search CV both will work perfectly. Okay. If the large parameter space, then don't go with the grid search CV. It will slow down your tuning the model, very slow down. It might take 1 hour, 2 hour, 3 hour, 4 hour, 5 hour. It depends. And it will eat your more computational power. Okay, then you can go with the randomized search CV. If you want a speed, definitely we will go with the randomized. Okay, and if you want the exact best parameter, then definitely you have to wait, you have to keep the patience, then you can go with the grid search CV. Okay, okay, so here I would like to give you the one more tip as well. What is that? What you can do, if you have, right, like the big data set, and you are interested to look for the exact best parameter, you don't want to use the randomized, right? In that case, you can pick up the sample data set. You don't need to pick up the whole data set. I will show you today. I did the same. Okay, so it is also good for the testing. Let me open my practical notebook. Here we go. Let me share my screen. Here we go. Okay, so this is I have just written down for your like the understanding number of estimator. This is the number of trees in the forest, maximum depth, minimum samples required to split an internal code. This is sample leaf, maximum feature, bootstrap. I'm not using all combination. We are using first three combination. If you want, you can try other two. Okay. Okay, so first we will here, this is I was telling you, I'm not picking up the whole data set because this is the very big data set, and it was taking too much time. So what I did, I just pick up the small combination. That is only the few rows you can see here. White train text, we are setting the some records 2000 up to 2000, this one from 0 to 2000 for the Y and X. And then we have set the here the parameters. This is the number of estimator. We have taken the 100, 150. You can make any, you can make changes. This is your choice. You can start with the 50-50 if you want to try it. You can start with the 100, 200. You can start with the like not 50-50, sorry, 50 or 100, and 100, 150, 200, something like that. Okay. And maximum depth I'm keeping 10. If you want, you can also make a 10, 20, 30, whatever you like. If you don't mention this, it will automatically by default, it will go till your model will understand. Okay. Then minimum like a sample split 2 and 5, sample leaf 1 or 2, and maximum feature we are using the square root. Okay. Here I would like to explain you what is the this square root. What does it mean? Like the maximum features the square root. What the square root means, this will reduces the correlation of the trees feature. Like for example, if there is 100 estimators, right? We are giving the 100 features. So it will take the square root of that one, then it will split up to the 10 features, right? It split the 10 features. So this is the very common practice when we are doing the grid search CV for the random forest model. Okay. And then we have the random forest classifier. We are setting the model. This is the same we did when we were building the model. This is the same code. There is a no difference. And we will run the grid search CV, number of job ones, scoring accuracy, threefold. Okay, we are taking the threefold, and then we are just write down the best model grid search CV dot best underscore estimator. This is an inbuilt parameter. I'm not making it. This is an inbuilt. It will print my best parameter at what best parameter highest accuracy. If you want, you can create a one data frame and you can print the each parameter accuracy, and then you can choose out of that one too. But if you use this directive, this one, it will only print the best parameter. That's it. Okay. And then we are doing the model prediction, and here we are storing. And now look at this one. I'm not going to run it in front of you because it took my so much time. So I'm just showing you the results here. So fitting three folds for each 16 candidates, totaling 48 fits. The best parameter is its maximum depth, none. Okay, maximum feature square root, and sample leaf 1, sample spread 5, and 150. So it is giving the highest accuracy. How much? 87. We were also getting the 87 earlier, right? And then here, but I picked up the small portion, okay, to look for the, because I'm testing. Now I found the best parameter. What I will do now next, here it is showing this much, like the accuracy positively it is going to predict, like come to know this one, and this is negative and this is neutral. If you want to check over previous result in the actual one, where is our random forest? I think this is the one. Okay, so it is 2329 280 17149. Okay, and now here, what the result we have? Here we go, it increased, right? So it is little bit increasing, I think, here. Okay, so you can do the comparison. And now what I did, I picked up the estimator which my model told me. Okay, so I will define this parameter. Here you can pick up only this one. This is minimum sample leaf 1. Sorry about that. So you can choose this one, and minimum sample split is only 5, and number of cliff estimate is 150, and maximum depth we will choose none, and rest I think same. And then you can run it on the whole your combination. Okay, so here you can do, I will keep it running because it will take some time. I forgot to make a changes in this. I think I have like forgot to change here, but this is I am picking up the whole data set now. Okay, I did not pick up the few sample because I found my best parameter, and I will train my model and see the accuracy again here with these parameters. So let it be run. It will take some time. And now just come on to the randomized search CV. Okay, sorry. So here we are using these combinations. Okay, everything is the same, and only the processing or strategy behind the randomized and grid search CV is, giving to give you the combination of each your fold, and give you the parameters of each combination. If you are interested to look for the each combination parameters, then go with the GridSearchCV. But randomized will pick up only the randomly. We don't know what it will pick up and give you the parameter of those one. Okay. And I have already shared what is the reason, right? It is a much faster than the full GridSearchCV. Okay. And then we are tuning this, and it is also showing almost the same accuracy for us. Okay. And this is the like your two methods, different methods, which will help you to hyper tune your model. And now you can choose the best model out of this, which parameters are working fine. Okay, and if you want to here print this one, we can print this one too. I did not print it, so let me print it here. Print best one. Okay, So let's see what are the best parameter it has like told us. The randomized your search CV. Okay. So let it be run. It will take some time. Mhm. Okay, so you can do one thing. It will take some time. Let it be. I will share the notebook with you as it is. Okay, and you will come to know the output. But you can print the best parameter here too. Okay, so it will show you. I forgot to print it. You can just print the best model. It will tell you the best parameter what the randomized has chosen. But it is giving us the same around accuracy, so you can use anyone. Okay. So this is the short and like the small video to share with you like how you can hypertune your model. You have learned the two different ways and I have tell you the difference as well and why we require the hypertuning and why you should prefer and how you should prefer, right? Just connect it with your real life. Then it is very easy to understand technology, technically AI. Okay. If you have any question, feel free to drop a comment. I will see you in the next session. Tomorrow I am conducting the live session on the customer segmentation. If you want to learn, just join me at 9 p.m. MST. So we will work together on the customer segmentation. Soon I will share the data set too tomorrow morning and then we will work together. If you I have posted one quiz today as well. Like if you are a college student, what kind of the hurdles on and the problems you are facing during your graduation or post graduation on which topic you want me to make a video, just drop a comment. It might help the more other students, right? So let's work together. Drop a comment, feel free. If you have any question and if you want to make me a video on any topic on which you are struggling a lot. Okay. Thank you so much. Keep patience, keep learning with science, data science. Thank you.